These are significance test notes 4. Today we're going to talk about one sample t-test and matched pairs t-tests. These are pretty similar tests, just like the confidence intervals were pretty comparable. You'll notice a lot of similarities between these two types of tests as well. We're going to start off with our hypotheses. In both of these types of tests, we're going to have some sort of question asking about, has a change occurred? For a one sample t-test, our null hypothesis, which we abbreviate H sub O, is that mu is typically going to be equal to something. Now it's okay here if you want to use less than or equal to or greater than or equal to, but equal to is sufficient. For our alternative hypothesis, H sub A colon mu is some sort of inequality, less than, greater than, or not equal to whatever this value was you established in the null hypothesis. For matched pairs t-test, we do have a null hypothesis as well. Our parameter we're going to be working with here isn't mu, it's mu sub diff, the mean difference. So we're going to be comparing two sets of data that can be paired, so there's going to be some sort of difference. We're going to assume in a matched pairs t-test that the mean difference is equal to 0, usually. So I'm going to put equals 0. I'm going to put in parentheses because typically the difference we look for in a matched pairs t-test is no difference. The alternative hypothesis is there is a difference. So typically you'll see mu sub diff equal or not be equal to 0, or be less than 0, or be greater than 0. I'm going to put 0 in parentheses because on occasion you may want the difference to be like 1 or something else, but usually it's 0. So once you're done with your hypotheses, we identify the procedure, which is either going to be a one sample t-test or matched pairs t-test, the parameter, which is going to be mu, and the population, which will be whatever the population is. So for one sample t-test, where mu is the mean whatever for all whatever the population is. For a matched pairs t-test, mu sub diff is the mean difference, or it may say mean increase or mean decrease of whatever you're talking about for all whoever your population is. We had mentioned before the conditions for a one sample t-test and matched pairs t-test are the same as the conditions for a one sample t-interval or matched pairs t-interval. You've taken a random sample from the population, and then the population is either normally distributed, or you have a large sample size, or once you do a normal probability plot, the normal probability plot is approximately linear, so it's not unreasonable to assume the population is normally distributed. Remember, for a normal probability plot, make sure you show a picture of it. For a one sample t-test, your data is most likely going to be in list 1. For a matched pairs t-test, you may have sets of data in list 1 and list 2 that you subtract. That list of differences appears in list 3, so you probably want to use list 3 for your normal probability plot. Step 3 with a test is to carry out the procedure. The first step is going to be to calculate the test statistic. For a one sample t-test, your test statistic is going to be t equals x bar minus mu sub 0 divided by standard deviation of the sample over the square root of n. It's pretty comparable to the one sample z-test, except we're using sigma instead of s and obviously t instead of z. For a matched pairs t-test, same idea, t equals x bar diff, the mean difference from the sample, minus mu sub 0, the mean listed in the null hypothesis, divided by s diff divided by the square root of n. When you carry out the procedure, you also calculate the degrees of freedom, which is equal to n minus 1. The size of your sample minus 1. The same thing is true on a matched pairs t-interval. And then you calculate the p-value. For that, we use stat test on your calculator. You will find this under stat test. And then both of these tests use the t-test feature, which is maybe number 2 on your calculator. You'll input data, and when we calculate this, you'll get a t-value and a p-value, excuse me. We'll do this shortly with a couple of examples. For t-test, you don't show the bell curve like we showed on the z-test. So it's sort of like on a z-test, show the bell curve. On a t-test, show degrees of freedom. Finally, you interpret your results. In both cases, you'll say since the p-value is either less than or greater than alpha, which is your significance level, for most cases you'll use something like 0.05 or 0.01 or something like that. You either reject or fail to reject the null hypothesis. There is or is not significant evidence that, and then you write the alternative hypothesis in words. Just to let you know, these are written in order, so if your p-value is less than 0.05, small values get rejected. If small values are significant, if something doesn't happen often, it's a significant event. So either circle or be working with less than, rejecting, and there is significant evidence, or you'll be working with greater than, fail to reject, and is not significant evidence. We're going to take a look at two examples, one of each type of problem. From the 2005 exam, we're going to look at a one-sample t-test, and from the 2007 exam, a matched pairs t-test. What I'm going to have you do is see if you can work your way through the steps for the 2005 problem. Pause the video, and we'll come back and we'll see if you've answered the problems correctly. Then we'll do the same for the 2007 test. So for this first problem, we're going to use a null hypothesis of mu is greater than or equal to 128. And we're going to use an alternative hypothesis of mu is less than 128. The question says, is there evidence to conclude the packaging is not in compliance? Not in compliance means that the number of fluid ounces is not at least 128. So if it's at least 128, we're in compliance, everything's fine. If it's not at least 128, we're going to use the less than inequality. One sample t-test, mu is the mean number of fluid ounces of milk. It does mention, highlighted here, mean number of fluid ounces of milk, the first highlighted item. For all containers of milk, the random sample of 12 containers is your sample, so the population would be all containers of milk from the milk processing line in the plant. Also highlighted is a random sample was taken, and you can also see normally distributed is highlighted. Variability in the filling process causes the actual contents of milk containers to be normally distributed. To find t, we run through our formula. Sample mean 127.2 minus the population mean from the null hypothesis, 128, over 2.1, standard deviation of the sample, over the square root of 12, your sample size. You can crunch that out on your calculator. If you do that, you should get negative 1.3197. Degrees of freedom is n minus 1, which would be 11, and the p-value is 0.107. Where we get the p-value from is using the stat test feature on your calculator. We're going to go down to t-test. We're going to select stats, and we're going to enter in the null hypothesis mean, 128, standard or sample mean, 127.2, standard deviation of the sample, 2.1, sample size of n is 12. I'm going to choose the less than inequality because that's the inequality that we used in the alternative hypothesis. And if we go down to calculate, you'll see that it does match our t-value that we calculated earlier, but we also get our p-value here, which is about 0.107. At the bottom of our screen, since the p-value is greater than alpha equals 0.05, or any alpha you probably chose, we fail to reject the null hypothesis. There is not sufficient evidence that the mean amount of milk in the containers is at least 128 fluid ounces. So if the p-value is big, we fail to reject it. Large values are not rejected. And then there is not significant evidence because large values, again, are not significant. That's how you set up this problem. See if you can work your way through the 2007 problem as well. Due to technical difficulties, we're not going to have the 2007 prob online. Answers will be provided in class, so check your answers in class for this problem. And this should take you through how to do the 2007 AP problem. Thanks.